Section 5.5, Quadratic Equations. The standard form of a quadratic equation is in the form of ax squared plus bx plus c equals 0. And a and b are coefficients of my variable terms, and c is my constant. A is not allowed to be 0. If it was, my x squared term would be eliminated, and if that would be the case, then what would be left is bx plus c equals 0, which is a linear function. Therefore, a cannot equal 0. The zero product property is an important property when solving quadratic equations by factoring. Here, if I have a product of factors, a times b equals 0, I'm allowed to state a equals 0 or b equals 0. Here's the procedure to do that. Here, a, b equals 0. If I would divide both sides by b, that would eliminate the b. Therefore, I'd be left with a equals 0. 0 divided by b is 0. Or if I wrote a, b equals 0, still a product of my factors, I divide both sides by a. A's would eliminate, b then would equal 0. And this will help us when I have a product of factors when I solve quadratic equations by factoring. So let's look at the procedure to solve quadratic equations by factoring. 1, we want to copy the problem. 2, we want to get the equation equal to 0 and order the terms. 3, factor completely. 4, solve for each expression by using zero product property, which was on the previous slide. Let's take a look at an example. Here I want to solve each equation by factoring. So what I want to do is use the standard form of a quadratic equation by setting this to 0. 2m squared plus m, subtract 1 on both sides, equals 0. First, I want to factor completely, so I'll check for a GCF. There isn't one that I can factor out, so I'll put a product of its factors, 2 sets of parentheses. 2m and m. 2m times m is 2m squared. 1 will break up 1 and 1. And since it's a minus sign, I know the terms have to subtract to get the middle term, and I know it has to be a plus minus or minus plus. Since my middle term is positive, I know that it has to be minus plus. Now I can use a product of its factors and the zero property rule. For example, if I have 2m minus 1 times m plus 1 equals 0, I can divide both sides by m plus 1, and I get 2m minus 1 equals 0. When I solve, I'll get 2m equals 1, or m equals 1/2. Now, I don't need to show this step every time. I just wanted to do it the first time to show you how this procedure works. Now what we have to do is do that for the other product of my factors. So what I'll have is, again, 2m minus 1 times m plus 1 equals 0. Now, divide both sides by 2m minus 1. That leaves me with m plus 1 equals 0. Solving, I get m equals a negative 1. So my possible solutions are m equals 1/2 or m equals a negative 1. Notice I have eliminated the extra procedures down here, and this is the procedure that we need to follow. Let's take a look at our next quadratic equation. Again, let's put it in standard form by setting to 0 and ordering. That gives me x squared minus 4x minus 12 equals 0. Now, when I factor, I notice I don't have a GCF that I can factor out, so I'll use product of its factors. So x and x times x is x squared. And I need to subtract to get my middle term, and I need a plus minus or minus plus. If I go through its factors, 6 minus 2 will give me 4, and 6 times 2 will give me 12. Since I need a minus for my middle term, this will be a minus and a plus, minus 6 plus 2. Using the zero factor property, x minus 6 equals 0. Therefore, x equals 6 when I solve. And x plus 2 equals 0. Solving, I get x minus 2, or x equals a negative 2. Possible solutions, x equals 6, x equals a negative 2. Again, on these examples, they want me to solve each equation by factoring. Let's put this in standard form. That will give me 25 x squared minus 10x, and I'll add 1 on both sides. And they're in order. There is no GCF that I can factor out, so I'll break it into its product of factors. Let's try 5x and 5x. 5x times 5x is 5x squared. And 1 will just have to break up into 1 and 1. And I know they have to add to give me my middle term. And it'll either be plus plus or minus minus. 5x and 5x does add to give me 10x, and it needs to be minus minus. Now, using the 0 product rule, I have 5x minus 1 equals 0. That gives me 5x equals 1, or x equals 1/5. Now we have to perform that same operation on my other factor. I'm going to have 5x minus 1 equals 0. Solving, I'm going to add 1 on both sides. 5x equals 1, or x equals 1/5. And here they turned out to be the same solution. X equals 1/5. Our next example, 3r squared minus 1 equals 0. It's already in standard form. It's set to 0. I do not have a middle term where r is an exponent of 1. Here I look to see if I can find a GCF. I can factor out a 3. That gives me r squared minus 9 equals 0. This is familiar to me. It is a difference of squares, so I need to factor again. So that's 3. And that would be r plus 3, r minus 3. And we're going to use our 0 property. And to do that, I need to do each single term. That's 3 of them. So here, I can divide both sides by r plus 3, r minus 3, and I get 3 equals 0. That is not true, so 3 does not equal 0. But I need to know that that's a possibility, just in case that's a variable here. My next product of factors is r plus 3 equals 0. R can equal a negative 3 when I solve that. And for my next one, r minus 3 equals 0. And when I solve, r equals 3. So here are my solutions. Again, I want to solve equations by factoring. I have 10n squared minus 10 equals 0. That's in standard form. I have a GCF. I'll factor out a 10. That leaves me n squared minus 1 equals 0. This is difference of squares. I bring down my 10, n plus 1, n minus 1, and then I use the 0 property. 10 does not equal 0. I still have to put that there as a reminder, just in case there's a variable there. Next, n plus 1 equals 0. Subtract 1 on both sides. I get n equals a negative 1. And finally, n minus 1 equals 0. Solving, I get n equals 1. And here are my solutions. My next example, again, it's in standard form. So I'll find a GCF. Here my GCF is 3n. So I'll factor out a 3n. That leaves me n minus 4 equals 0. When I use the product rule, and this is why I practiced the 10 on this one, I need to set this term equal to 0. And when I do, that's going to give me 3n equals 0. Divide both sides by 3, n equals 0. That's one of my solutions. Next, I have n minus 4 equals 0. Add 4 to both sides, n equals 4. So here are my solutions. So always remember, we have to put this term on the outside and set that equal to 0, because I can get a possible solution for that term. My next example, again, I'm factoring to solve my equation. I'm going to put this in standard form. 4y squared minus 32y equals 0. I have a GCF, it's 4y. And when I factor, I'm going to get y minus 8 equals 0. The zero property rule, I'm going to get 4y equals 0. Divide by 4 on both sides, y equals 0. That's one of my solutions. And I have y minus 8 equals 0 and y equals 8 when I solve. And here are my solutions. On my next example, I want to put in standard form. That's a negative 2x squared plus 8. I factor my GCF. That's a negative 2. That leaves me x squared minus 4 equals 0. I can test that by the distributive property. Negative 2 times x squared is a negative 2x squared. Negative 2 times a negative 4 is a positive 8. This is a difference of squares, so I have to continue factoring. X plus 2, x minus 2 equals 0. Again, I have the first term out here. Negative 2 does not equal 0, but I still want to put that there. X plus 2 equals 0. Solving, I get x equals a negative 2. And finally, x minus 2 equals 0. And when I solve, I get x equal to 2. And here's my solution. Next, we want to solve equations by finding the square roots. This will be used in one case. This is when only a squared and a constant term are available. There is no term with an exponent of 1. In other words, there's no linear term. Number 1, we want to get the squared term by itself. Number 2, get the coefficient of the squared term to a positive 1. Number 3, take the square root of both sides. Number 4, don't forget the plus and minus sign for the solution. Before we solve these examples using square roots, let's take a look at the quadratic equation. Here we have a term that has a squared exponent, and we have a constant. We don't have a linear term. Again, we have a term with a variable that is squared and a constant, no linear term. When this is the case, we can use the procedure solving equations by finding the square roots. Our first example, we want to solve each equation by finding the square root. We're given a negative 2x squared plus 12 equals a negative 60. We want to isolate the x squared term, get it by itself. So we'll subtract 12 on both sides. That gives me a negative 2x squared equals a negative 72. Get the coefficient to be a positive 1 by dividing by a negative 2. X squared is equal to 36. Now we can take the square root of both sides. And that leaves me x equal to plus or minus the square root of 36, which simplifies to 6. Our next example, a negative 4x squared equals a negative 49. Here, I can divide by a negative 4 on each side. Because I already have my squared term isolated, I just need to get the coefficient to be a positive 1. That gives me x squared equal to 49 over 4. Now I can take the square root of both sides. And when I do, that gives me x equal to, and I can simplify this to look like this, the square root of 49 over the square root of 4. Or I could leave it under one radical. In either case, that gives me plus or minus the square root of 49 is 7 over the square root of 4, which is 2, plus or minus 7 halves. Our next example, I have 7x squared minus 8 equals 6. I'm going to isolate my x squared by adding 8 on both sides. That gives me 7x squared equals 14. Divide by 7. That gives me x squared equal to 2. Take the square root of both sides. That gives me x equal to plus or minus the square root of 2. This is already in simplest form. Again, I want to isolate my x squared term. I'm going to add 120 to both sides. 3x squared equals 120. Divide by 3 to get the coefficient to be a positive 1. That gives me x squared equal to 120 divided by 3 is 40. Take the square root of both sides. And when I do, that gives me plus or minus the square root of 4 times 10. And we know the square root of 4 is 2. So that's plus or minus 2 square roots of 10.